Yes, it's Elton again. Be greeted. Welcome to Maths and Science series. Today, we'll be doing mechanical energy with you, grade 10 learners. But before we can continue, I'd like to thank those who subscribe to the channel. If you haven't subscribed yet, please do that. Do not forget to like, share, and comment. Now, today we'll be doing mechanical energy. Specifically, we are going to touch the potential energy, the kinetic energy, as well as the potential gravitational energy. Okay, from the earlier grade, you were taught or you were told what energy is. So energy is simply the ability to do work. It means that there's nothing you can do without having the ability to do that something. So for you to do something, you have to be energized. All right, now what you need to understand or what you know about energy is that all energies, they are measured in joules. Joules, okay, that's a term that we're going to talk a lot about here in energy, because since we're going to talk about energy throughout this topic, we are going to talk a lot about the SI unit of energy. Now we have those two energies that you see on your screen. The potential energy, it is very important for you to know that potential energy can be calculated and potential energy can be calculated, as well as the kinetic energy. Opposite is true. Now, what is potential energy? If they ask you to define the term potential energy, you just have to say potential energy is the energy an object has due to its position. An energy an object has due to its position. Take that first P as if it stands for position, because some other learners have noticed that when they ask them to define potential energy, they write the definition of a kinetic energy. So since potential energy starts with a P, take that first P as what as the position. Then when you define it, you say that a potential energy is the energy an object has due to its position. So it means that when we have an object that it is placed on a higher level, that object, it is going to have more potential energy because of its higher state or higher level of placement. I don't know if you understand that. But since I said that you must know how to define potential energy and on how to calculate potential energy, when you calculate potential energy, it means that there's something or you cannot calculate something without a formula, right? Now, potential energy have a formula that says EP equals mgh. EP equals mgh. Let me just erase this, then we'll talk about it after discussing about the potential energy. Now, as you can see that we are having EP that equals mgh. EP obviously is the potential energy measured in joules, since I said that all energies are measured in joules. So it is very important for you to know the SI units of these formulas. Now, the M stands for mass, measured in kg. Then G, it is the gravitational constant, of 9.8 meters per second squared. We'll discuss about it. Now H becomes the perpendicular height. All right, now EP equal to mgh. Now we are having EP as potential energy measured in joules, mass measured in kg. What about G? It is the gravitational constant of 9.8 meters per second squared. So you are already given the G. So in that formula, you can be asked to calculate EP or mass or the H. But you won't be asked to calculate the G because you are already given. It's a gravitational constant of 9.8 meters per second squared. So all the time, make sure that you know it by heart. Now we have H, which is the perpendicular height measured in meters. It is measured in meters. It is measured in meters. So that's very, very important for you guys to know. So guys, since you can see that mass is measured in kg and the perpendicular height is measured in meters, sometimes they can give you other SI units, so you will be compelled to do what, to convert them to the correct SI units. Now, it is very important for you to know the conventions. I don't know if this is how you write it, but it doesn't matter. You understand what I'm saying. Now, mass, it is measured in kg, right? But if they can give you grams, it is very important for you to know how to convert it to kilograms. So if they give you, if it happens they give you grams, for you to convert grams to kg, you have to divide grams by 1,000. I don't know if you understand. For an example, let me say we have 150 grams. For me to do what, to convert 150 grams to the kg, we will have, you punch in your calculator, you will have 0.15 kg. So simply for you to convert grams to kg, you have to do what? You have to divide by 1,000. Automatically, the answer that you're going to get, it will be already measured in kg. Since you did what? You divided by 1,000. I hope that's clear. It is very important for you to know that. Now, let's come to the perpendicular height, h. We know that h is measured in meters. But now, if they can give you centimeters, for you to convert centimeters into meters, you have to do what? You have to multiply centimeters by 10 to the power negative 2. Then for you to do what? To convert millimeters to meters, you multiply by 10 to the power negative 3. Your answer, or the answer that you will get, it will be already in the measurements of meters. I don't know if you understand it, but it is very, very important for you to know or to understand what we are doing here. That's very important. Okay, let's just do one example that requires us to do to calculate for the potential energy. Okay, let's try this example, then we continue. Just do two examples that requires us or that talks about the potential energy. So how high must a 400 kg weight be lifted above the earth so that its potential energy is 9,800 joules? Now let's just collect our data. Collect your data first. You are given kg, that's mass, right? 400 kg. You are given the potential energy in joules, which is EP, equals what? 9,800 joules. We obviously know the G, it's what? 9.8 meters per second squared. So it means that the question wants us to do what? To calculate for h, or the perpendicular height. Since the question out says that how high, so we are actually talking about the height, right? Now we write the formula that is EP equal to mgh. Now you just substitute your data. So the most important thing, or why did I write the data aside? It helps me to do it, to see which variable are they looking for, or are they wanting me to solve or to determine. Now we already have EP. Since I told you that this formula actually, it won't ask you to calculate EP only, but you can calculate EP provided you are given the mass and the height. You can calculate mass provided you are given the EP and the height. You can calculate the height provided that you are given the EP and the mass in kg. Okay, we are happy with the SI units there because those are the correct ones. Now, what is the value of EP? It is 9,800 equals M. 409.8 times H, right? Times H. What I can do now, you just have to use your calculators. You multiply whatever that we are having on our right, or you just divide with everything that we have here. 409.8, so that we can make H the subject of the formula, right? 9.8. Then these, they cancel. Then we are left with H on the right hand side. But what about on the left hand side? The answer that we're going to get here, it will be 2.5. But we know that we're calculating the perpendicular height, and the perpendicular height, it is measured in what? In meters. Now we write what? Meters. So it is very important. Make sure that when they ask you to calculate mass, make sure that at the end of your answer, when you got your answer, write its SI units. I don't know if you understand that. So this formula, it won't specifically want you to calculate EP only, but you can be asked to calculate M or H, provided that you are given those other variables of the equation or of the formula. I don't know if you understand that. So let's go to the second example where this is actually the last example of or that talks or that deals with potential energy. So this will be doing the last example of potential energy, then we discuss about the kinetic energy. I hope that you understood whatever that I'm doing here. If you didn't understand it, make sure that you pause the video and start it afresh. Okay, let's do the second example. Okay, the second example, what is the potential energy of a 500 kg metal piece of a bridge structure if a crane is holding it 3 meters up in the air? So the most important thing, we write first what the data. We have kg, that's mass, right? Then we have 3 meters, that's the height. Now what about G? It's 9.8 meters per second squared. Obviously, we can see that they want us to do what? To calculate for EP. They want us to calculate EP. Yes, even the question, they say that what is the potential energy? So they want you to calculate potential energy. So you calculate potential energy provided that all of these variables here are given. Mass is 500 kg, it is in correct SI units, 9.8 times the 3. So it's very important for you to know how to interpret them. So let me just use my calculator to punch that so we can have our answer. 500 times 9.8 times 3. I don't know if my calculator is correct, but it says that 14,700. I don't trust this calculator, but let me just write it. 14,700 joules. So if this answer is incorrect, you can correct it and leave the correct answer on the comment platform. I'm not sure if it's correct or not. I don't trust this calculator of mine sometimes. Yeah. Okay, so this is how we actually calculating the potential energy. Okay, let's talk about the kinetic energy. Kinetic energy. The kinetic energy. The word kinetic, it tells us with movement or motion. So when we define kinetic energy, we say that an energy an object has due to its motion. What does that mean? It means that all moving objects have kinetic energy. I don't know if you understand that. And kinetic energy can be calculated as we were doing with what? With the potential energy. This is the formula for calculating kinetic energy, or mass, or the volume under the kinetic energy. So EK is what? The kinetic energy measured in joules. Then half is half. M, it is the mass measured in kg. V, it is the velocity, not volume. Velocity measured in meters per second. So it is very important for you to know these SI units of this formula. Alright, so when we come here to the velocity, they can give you kilometers per hour. Then they want you to do what? To convert it to meters per second. You simply divide by 3.6. Do not forget that. It is usually 2 marks. But when they can also give you meters per second, then they want you to do what? To convert it to kilometers per hour. You just multiply it by 3.6. So for you to convert kilometers per hour to meters per second, you simply have to divide by 3.6. But if you are given meters per second, then they want you to convert it to kilometers per hour. You simply have to multiply the meters per second by 3.6. 3.6. For an example, let me say you are given 14 kilometers per hour. Let me say you're given 14 kilometers per hour. Then they want you to convert it to meters per second. Then what you have to do, you have to divide it by 3.6. Then you have your answer. That answer that you have, it will be already in what? In meters per second. I hope we understand each other there. Okay, let's just do our first example, then we continue. Okay, calculate the kinetic energy of a 150 kg golf ball moving at 5 meters per second. You collect the data, do not forget that. Now, 150 kg is actually the mass. It's the mass 150 kg, and it is in its correct unit. Moving at 5 meters per second, that's the velocity. 5 meters per second. Now they say calculate kinetic energy. So we want EK. We don't have it. So you just write the formula, half mv squared. That's the first thing for you to do. Don't just substitute without writing the formula first as your first step. Now EK equals half. What is the value of m? It is 150. What is the value of v? It is 5. Then you don't forget to write what? The square. Then you punch everything on your calculators. Now, since you punch everything on your calculators, you're going to have the answer. Since I don't trust this calculator of mine, okay, I don't have a calculator actually here. I was just using the cell phone calculator. Sometimes it gives wrong answers. So the answer that you're going to get here, you're going to get that answer, then you write joules. So that will be the EK. That will be the EK. So this formula, it doesn't specifically want you to calculate only EK. They can want you to calculate EK only if M and V, they are provided on the statement. Or you can calculate mass provided that you're given EK and the velocity. I hope we are together there. Now let's continue let's talk about the mechanical energy. Let's talk about the mechanical energy. So what is mechanical energy? Sometimes they can want you to define that. Mechanical energy, it is the sum of the kinetic energy and the potential energy of an object. That is how you are required to define it. Mechanical energy, it is the sum of the potential energy and the kinetic energy of an object. So when you talk about the sum, it is the addition of kinetic energy and the potential energy of an object. It is very important for you to know how to define mechanical energy. So the formula for calculating mechanical energy is EM equals EP plus EK. This is actually the definition, or this is what the definition says about mechanical energy. As I'm saying, that it is very important for you to know how to define mechanical energy. Mechanical energy, it is the addition, or it is the sum of the potential energy as well as the kinetic energy. EM is the mechanical energy measured in joules equal to EP. Let me just simplify that. We know that EP, it is mgh plus EK, it is half mv squared. So this is the formula for doing what? For calculating the mechanical energy. So if they will ask you to calculate mechanical energy, you must be, for an example, let me say you are given EP as 9,800 joules. Then you are given EK as, okay, let me do this. You are given EP as 100 joules and you are given EK as let me say 200 joules, right? Then they want you to calculate EM, or the mechanical energy. Since we have the since we are having the kinetic energy and the potential energy, for us to get the mechanical energy, we have to sum these two energies for us to get mechanical energy. I don't know if you understand that. So here, if they ask you to calculate for the mechanical energy, or if they ask you to calculate mechanical energy, you need to make sure that you already have EP and EK, so that you can calculate, so that you can add them to give you the mechanical energy. I don't know if you understand that. Now here, let me say we're given a statement like this, that you are given EP as 100 joules and EK as 200 joules, and they want you to calculate what? EM. What is that you're going to say? You're going to EM equal to mgh, or EM equal to EP plus EK. Then we know that EP equals what? Equals 100 plus EK. What is EK? It is 200. It means that EM, it will be 300 joules, because we're saying that EM, it is what? It is the sum, or it is the addition of EK and EP. I hope we are together there. So make sure that you know these two. Make sure that you know it. It is very, very important. Now, since we know, I don't know why I erased it. Sometimes they can give you EM and EP, then they want you to solve for EK. It is very easy. If you have this, let me say it's 200 joules, then you have this as what? As 100 joules. Then they want you to calculate for EK. Transpose that on the right, on the left, you have 200 joules minus 100 joules equals EK. Then you'll have EK as 100 joules. As easy as that. But it's very important for you to know this. It is very, very, very important. Okay, there's this principle. This is the last part. There's this principle like you have to familiarize yourself with. It is called the principle of conservation of mechanical energy. So it is very important for you to know how to use this principle and for you to know how to define it. So when we define the principle of mechanical energy, I won't write it down, I'll just call it out. You'll be writing as you are listening. Now, the principle of conservation of mechanical energy states that the total of mechanical energy in an isolated system remains constant. So that's the easiest way of defining the principle of conservation of mechanical energy. We say that the total of mechanical energy in an isolated system remains constant. And there's this other one that is more simplified. We can say that the sum of the kinetic energy and the potential energy in an isolated system remains conserved or remains constant. So that is how you are defining it, but I will urge you to use this one that says the total mechanical energy of an isolated system remains constant. Just use that one because my learners are also using that one. I told them to use that easiest one. Okay, now we have the formula for calculating this, or the principle of conservation of mechanical energy has its own formula. So since you can see that it is written on your screen, the principle of conservation of mechanical energy. Now don't just mix or don't just complicate things saying that when they ask you to define mechanical energy, you define the principle of conservation of mechanical energy. No. When they ask you to to define mechanical energy, you have to say the total the sum of EP and EK, or the sum of kinetic energy and the potential energy of an object. But when they ask you to define the principle of conservation of mechanical energy, you simply have to say the total mechanical energy of an isolated system remains conserved or remains constant. So we have EM1 equals EM2, where EM1, this is mechanical energy, and mechanical energy equals what? EP1 plus EK1 equals EP2 plus EK2. So we have to simplify it further so that we can have a more simplified formula. So they use this formula a lot in past question papers. Now EP1, we know that EP is equivalent to mgh. So we write mgh1 plus half mv1 squared equals mgh2 plus half mv2 squared. All right, now this formula is used to calculate the velocity. Mostly they ask you to calculate the velocity of whatever object that they are discussing about on that scenario. Now we have m on the left hand side, or on the side of EM1. We have m on the right hand side of the side of EM2. So all of these m's, they represent the same mass. So if in a scenario they are talking about a 1 kg object, so that 1 kg object is equivalent to all these or these masses that you can see in the principle of conservation of mechanical energy. Now the G, we know that G is what? 9.8 meters per second squared. What about the H? We have the first height or the initial height as well as the final height. We have the velocity or the initial velocity as well as the final velocity. So most of many questions they ask you to calculate the velocity. It can be the initial velocity or the final velocity. So it is very important for you to know how to use this formula. The most important thing, make sure that you do what? You write the data aside before you can use this formula, before you can calculate whatever they want you to calculate. So this is how this thing of principle of mechanical energy or the principle of conservation of mechanical energy goes. So they will ask you to do what? To define the principle of conservation of mechanical energy, then you define it. Maybe in 1.2 or question 1.2, they will say that use the principle stated in question 1 to calculate the velocity. I don't know if you understand that. In question 1, for an example, they will ask you to do it to define the principle of conservation of mechanical energy. Then in question 2, they will say that use the principle stated in question 1 to calculate the velocity. Like they won't be specific on which velocity are you to calculate or are you required to calculate. So by writing the data and understanding the statement, that is how you're going to know which velocity are you required to calculate. Yes guys, so make sure that you try to attempt question papers to see if you understood. These are actually the notes. We haven't done much of the things here, but for you to use the principle of conservation of mechanical energy, you must understand the statement and all the diagrams that they're going to give you guys. So make sure that you understand the English written there. Alright. There's this thing that I forgot to tell you about the gravitational potential energy. Gravitational potential energy. So when you define it, you say that the gravitational potential energy, it is the energy an object has due to its position in the gravitational field relative to some reference point. The potential energy an object has due to its position in the gravitational field relative to some reference points. That is how you are to define it. So you know that the formula for calculating the potential energy is mgh. So even when they ask you to calculate the gravitational potential energy, you also use that formula of calculating EP. But when you are defining potential energy and the gravitational potential energy, when you define potential energy, say that the energy an object has due to its position, right? But when you are to define gravitational potential energy, you continue with the definition of the potential energy, saying that the gravitational potential energy, it is an energy an object has due to its position in the gravitational field relative to some reference point. So this was the end of our lesson. So please make sure you use or you try to attempt past question papers to see if you understood whatever that we were doing here. So make sure that you understand the principle of conservation of mechanical energy, please guys. So please do not forget to subscribe to the channel as a way of promoting us so that other people can get the help that you got. Okay, this was just the last part. Please make sure you understood everything. If it takes you guys to repeat the video maybe 2 times or 3 times, just do that for you to do it, to understand whatever that I explained there, and use past question papers. Thank you.